Applications or the uses of potentiometer. So in this video we shall see about the first application of potentiometer, and this application is to compare the EMF of two given primary cells. So for that we need this circuit connection here. Everything is the same like before, only the only extra components we have connected here are two cells having EMF E1 and E2, a galvanometer, and this point, it is a touching point which touch the wire, and this is a jockey. What do we call this point? This is a Jockey. Okay. This is a two-way key. So in this two-way key, it means I have three pins, A, B and C, and this point C, it is actually a common point which you can connect either the first cell or the second cell. So if you joined point A and point C, it means you are connecting the first cell with the circuit, and if you joined the point B and C, you are connecting the second cell in the circuit. Okay, all right. So now, in order to compare the EMF of two cells, I will first set the rheostat. I will adjust and fix the positions of the rheostat so that a constant current I will be flowing through the wire in this way. And this constant current I, it is actually produced by the battery when the key K is up, is on. Okay. So we have seen that when the constant current is passing through the wire, the potential drop across any length of the wire, it is directly proportional to L, or V is equals to KL. So please note this point. Now, let me introduce the cell E1 into the circuit. That is by connecting the 2 points A and C. So if you connect the point A and C, the cell E1 here, it is said to be in the circuit. Okay. So because this is the positive terminal of the cell, so now this cell E1, it is functioning here, so therefore it will send out a current. It will send out a current, and this current will be flowing in this direction. It reaches a point A and then it goes there, it goes to the galvanometer, and then it comes back to the cell. Okay, so what happened is, if I take this jockey and I slide along the wire till I get a zero deflection in the galvanometer. So when you get a zero deflection in the galvanometer, it means that the current, right, in this circuit, it is zero. So let me name the point, this point, as G1. And the length of this part here, let's say it is L1. Okay. So as you know, because the EMF in this case, it is E1, and this EMF, it is sending a current, right? In which direction? In this direction, in anti-clockwise direction. But looking at this current I, which is sent by the battery, this current I, it is flowing through the wire in this direction. So which means this current I, it is flowing in opposite direction, which means in clockwise direction. So now, out of these two current, which current will flow through the wire? Which current will flow through the wire? So for that, let me give you an example. If I have two cells connected like this. This is the first cell of EMF E1. This is second cell E2. Now both cells will produce a current. Let's say this cell is E1 is giving out a current I1, and the cell E2 it is giving out a current I2. Now if you consider the first cell E1, then this current E1 it has to flow like this, and it will pass through this external resistance. Similarly, this current I2 it has to pass through the circuit in this way. But because the two currents are in opposite direction, so therefore they will interfere each other, and the current at this external resistance will be the current due to one cells only. So how is that possible? So for that, right, we will imagine in this way. If this current I1 it is stronger than current I2, then this current I1 will dominate current I2, which means current I1 now will flow through the resistance. Similarly, if current I2 is stronger than I1, then this I2 will flow through the external resistance, capital R. So whichever current it is greater here, then that current will always flow through the circuit. So similarly, because as I told you, we have two currents in this potentiometer wire. One current is due to capital I, which is in this way, and the other current is due to the EMF E1, which is in this way. So now, when these two currents, they are passing through the potentiometer wire, so they will interfere against each other. But the condition here is the galvanometer, right? When you touch the jockey at this point, the galvanometer stands at 0 position. So what does it mean? It means that at 0 position, the current I, which is sending by the battery, and the current which is produced by the cells E1 are equal. So that means there is no net current which is passing through the potentiometer. So in that case, I will write, because if you remember in my previous lecture videos, we have E is equals to V minus IR. Okay. So this E, it is the EMF of this cell, that is E1 in this case, and this V, it is the potential difference across the 2 point A and J1 when the current is sending by the cells E1 only. And this I, it is actually the current which is produced by the cells E1, so that will be I1. And this R, this small r here, it is the internal resistance of the cells E1. Okay. But at this point J, when the galvanometer shows zero deflection, it means there is no current. There is no current in the potentiometer. So when there is no current, so I1, which is the current due to the cells E1, it will be 0. So when I1 is 0, so this term will disappear. So you'll have only E1 is equals to V1. Okay. That means the EMF of the cell is the same as the potential difference. Okay. Now, for potential difference, coming back to this equation, we have V, the potential difference, which is the difference between, the potential between 2 points. It is equals to KL. So for this V1, I will write it as K, because the length that I'm considering here, it is L1, so I'll write KL1. Okay, so we have E1 is equals to KL1. Okay, so next what I will do is, I will disconnect the point A and C. Now I will connect B and C. So if you connect B and C, you are introducing the cells E2 into the circuit. So similarly, like before, I will slide this jockey along the wire till I get a 0 deflections in the galvanometer. So when my galvanometer shows zero deflection, let's say it happens when I touch the jockey at J2. And if this length is L2, then I can see here that E2, which is the EMF of the second cell, is equals to KL2. Okay. Now from these two equations, when I divide E1 upon E2, I will get KL1 by KL2. This K with this K cancel. So only E1 it will be E2 times L1 upon L2. Okay. So look at this equation. Now if this EMF E2, let's say it is a standard cell whose value is known, L1 and L2. L1 and L2, they are, the length of the wire. So this length of the wire, right, it can be read out from the scale which is there in the potentiometer itself. So therefore, all the terms here, E2, L1, L2 are known. So if all these are known, then E1 also can be determined using this equation. So this is how we use a potentiometer to compare the EMF of two cells, or to find out the unknown EMF when one EMF is known. So this is about the comparisons of EMF of two cells.